Hi everyone, my name is Ehsan. Today I'm presenting our work on intelligent traffic monitoring with hybrid AI. This work has been done in collaboration with Alessandro Oltramari from Bosch in Pittsburgh. Challenges in intelligent traffic monitoring, or ITMo in short, are exacerbated by large quantity and modalities of data that needs to be first pre-processed, stored, and then fed into the state-of-the-art reasoners to obtain the results. We formulate the problem of ITMo as driving actionable knowledge from multi-modal real-time and related knowledge over traffic data that include traffic camera or other sensory information. There are challenges associated with any system that is trying to solve ITMo. First, we are dealing with a large quantity of multimodal information that needs to be fused together. Second, any such system should have background knowledge acquisition mechanism to obtain common sense information or other information related to traffic. For example, any such system should know social contracts in different localities such as Pittsburgh left. Any such system should also have clear domain knowledge. It should be able to obtain weather information, topological road information, or any other domain information related to traffic, for example, how the traffic light works. Beyond the three main ones, any system trying to address ITMo should be flexible enough to support an incremental design strategy. This is become more important given the fast pace of research in the field. Also, such systems should be easily integratable into state-of-the-art reasoners that can include language models or visual language models. And finally, it should be robust enough to handle the level of noise that we see in such systems. To address all of these issues, we propose HANS, Human-Assisted Neuro-Symbolic Architecture for Multimodal Context Understanding. Here we have listed the details of HANS, and you can also see the different components in HANS. HANS starts from the video feeds and uses off-the-shelf object detectors to extract scene information, and through its symbolic knowledge, it fuses it with background knowledge and common sense information. And it's also flexible enough to handle a large variety of neuro-symbolic reasoning methods that can include symbolic ones and neurals. Now let's dive into evaluation with 4 different reasoners. For the evaluation part, we showcase 4 different reasoners and the results that you can get by implementing them on top of HANS. The first example is an implementation of Mupello et al., which is a symbolic reasoner. In this work, they heuristically use the amount of deviation between each frame of the video feed from the median frame as a proxy for as a proxy for congestion in traffic. As a different symbolic method, we have an on-the-fly annotation process through a GUI that gives our human annotators a way to look at the data and query the data. Going beyond the symbolic reasoning to more advanced one, HANS has the ability to integrate with reasoning algorithms based on graph structure that include graph embedding or etc. Here we have examples from the use of knowledge graph structure for scene similarity search. In the table in the left, you can see an example of queries that can be fed into the system, and the column in the right contains the description of the best match frame. Here you can see in the example, the query has asked for a scene with 3 objects and 2 of them being a car, and the best match, as you can see, has 3 objects, 1 of them being a bike and 2 of them being a car, etc. HANS has also the ability to integrate with language models. Here we have presented the results of fine-tuning Roberta Large on background knowledge from HANS and evaluating it on the results. Here's a really short overview of our work. If you are interested, please feel free to read the paper or reach out to me or any of the collaborators. Thank you.